Linear simultaneous equations. Let's begin by looking at an example. X squared plus y squared equals 25 and y minus 3x equals 13. Before we go into solving these simultaneous equations algebraically, I just want to show you why we're doing it and what it represents. Now, our first equation in this example is a non-linear equation. What that means, if we were to plot this on an xy axis, you do not get a graph of a straight line. X squared plus y squared equals r squared is the general equation for a circle. So in our example, if r squared equals 25, that's to say the radius of our circle is 5. Which means the centre point of the circle being 0, 0, it will cross the axes at 5 and minus 5. So we can sketch our circle. Our second equation in this example is a linear equation, which means it's in the form of y equals mx plus c. We can rearrange this equation to give us y equals 3x plus 13. So I've done that by adding the 3x to both sides of the equation. If we plotted this on our axes, what we would see is a straight line looking something like that. When we're solving these simultaneous equations, what we're looking for is the coordinates of intersection where your straight line crosses the circle. That assumes that the linear equation intersects your circle. However, if we're looking at another example of a nonlinear simultaneous equation, and your linear equation is a tangent of a circle, a tangent is a straight line that touches a curve, what we would see that it only touches your circle at one coordinate. So you will only get one value of x and one value of y. So the two different types of example questions you will get, you will either have them set out like this and the question will ask solve algebraically, or you will get a question and they will draw the axes for you and your circle and your straight line, and you need to identify the coordinates of intersection. Occasionally you're asked to prove perhaps that the linear equation is the tangent to the circle. Is it a tangent or does it intersect? And you have to show that algebraically. And you do that by the following method that we're going to look at shortly. If it's a tangent, you will only get one solution for x and one solution for y. If it intersects, you will get two solutions for x and two solutions for y. So let's begin with our method on how we begin solving these simultaneous equations. So I'm going to just rewrite our nonlinear simultaneous equation and our linear simultaneous equation. Now, step 1. In this method, step 1 is identify your linear equation and either make y the subject or make x the subject. For our linear equation in this example, it's easier for us to make y the subject. Y equals 3x plus 13. The reason as to why we're doing this is it allows us to move on to step 2, which is to substitute. Because we essentially know what y is 3x plus 13, it allows us to substitute this into our non-linear equation. Just to note, your non-linear equation may be that of a circle or it may be that of a quadratic. So we substitute. We have x squared plus y squared, but y is now 3x plus 13 squared equals 25. If we have our brackets and we're squaring them, we're going to write that out as double brackets, 3x plus 13 multiplied by itself. We're going to show every step of our working. We're going to expand those brackets. X squared plus 3x times 3x is 9x squared. 3x times 13 is 39x. 13 times 3 is 39x. And then 13 times 13 is 169. And that equals 25. Our next step is to collect any like terms. So, x squared plus 9x squared is 10x squared. 39x plus 39x is plus 78x. Plus 169 equals 25. At this stage, you'll have something that looks a bit like a quadratic, ax squared plus bx plus c. You can solve quadratics when they are equal to 0. Step 3 is get your quadratic equaling to 0. Because that's going to allow us to solve by either factorising or using the quadratic formula. To get this to equal to 0, we're going to subtract 25 from both sides. That leaves us with 10x squared plus 78x plus 144 equals 0. At this stage, we're going to try and factorise. Now, to make this a bit easier for us, 10, 78 and 144 are all even numbers, so we're just going to divide this by 2 just to make the numbers a little bit smaller. That's not changing the value of x. It's just going to make it easiest for us to factorise. Step 3 is to solve our quadratic. So I'm going to factorise this. So I'm going to use the AC method of factorising because my value for a, the coefficient in front of the x squared, is greater than 1. If you're unsure on the AC method, please watch the video on how to factorise quadratics. So I'm going to start with 5x squared multiplied by 72. That leaves me with 360. I'm now looking for my factors of 360, so two values that times to 360, but they add to 39x. So this may take some time. My factors are 15x, so 15 multiplied by 24 is 360, and 15 plus 24 is 39. My next step is to replace the 39x with my factors, so that's 5x squared plus 15x plus 24x plus 72. Split this in half and factorise each half individually. Common factor of 5x squared and 15x is 5x, so we take that out and x plus 3 goes in our bracket. And then common factor of 24x and 72 is 24, leaving us with x plus 3. Which means x plus 3 is one of our brackets and 5x plus 24 is the other. Five x plus 24 multiplied by x plus 3. Now we solve those, so that's saying that each of our brackets is equal to 0, so 5x plus 24 is equal to 0 and x plus 3 is equal to 0. So we take 24 from both sides, so 5x equals minus 24, and then we divide both sides by 5, so x equals minus 4.8. That is one of our values of x. If x plus 3 equals 0, we take 3 from both sides, so x equals minus 3. And that's our other x coordinate. So we take it back to our simultaneous equations right at the beginning, and we can see that we made y the subject, y equals 3x plus 13. So we want to find the y coordinate. So step 4 is to substitute those values of x back into our linear equation so that we can find the y coordinates. So y equals 3 multiplied by minus 4.8 plus 13, and y equals 3 multiplied by minus 3 plus 13. 3 multiplied by minus 4.8 is minus 14.4. Add 13, minus 1.4, and that is our y coordinate. And then 3 times minus 3 is minus 9, and we add 13 and we get 4. So we can then write this as coordinates if we want. So when x was minus 4.8, y is minus 1.4. And when x was minus 3, y is 4. So let's link this back to our graph that we looked at right at the beginning. We know that our straight line crosses our circle at coordinates minus 3, 4, and minus 4.8 and minus 1.4. So graphically speaking, that's the purpose of what we've just been doing, to find the coordinates of the intersection.